Hello everyone, it's a pleasure meeting you all in my mathematics class. I have already discussed how the nth derivative of a function could be found. You can just go to my earlier videos and find out how the problem has been done. Today I will teach you how to find the nth derivative of compound functions such as uv, that is finding the nth derivative of compound function as ub, where u and v are functions of x. So for this I use what is called the Leibinitz theorem. And what does Leibinitz theorem states is that if u and v are functions of x and n is a positive integer, it must be a positive and it is also an integer, then the nth derivative of uv is given as un, nth derivative of u multiplied by v, plus nc1 into n minus 1th derivative of u into the first derivative of v, plus nc2 into second derivative n minus 2th derivative of u multiplied by second derivative of v, and like that it goes on. It's here, it is ncn is 1, u into the nth derivative of v. Proving this theorem is very simple, but I am not going to do that. I will teach you the application of Leibniz theorem in this problem, and also I will take another problem specifically to make you understand how this Leibniz theorem is applied. That I will do. Now, what does the Leibniz theorem states? If u and v are functions of x, then the nth derivative of u is given as u and v, where n is a positive integer. It is a positive integer, and u and v are functions of x. Then u and v plus nc1 n by un minus 1 v1 plus nc2 un minus 2 v2, etc. It goes up to uvn, where this un minus 1 means what? N minus 1 the derivative of u, or vn minus 2 means n minus 2 the derivative of v. So this is our understanding. Okay. Now I will take up this problem, and I will take a simple problem to make you understand how this is Leibniz theorem is applied to the problems that I will take. Coming to this problem, you are given in is equal to nth derivative of the function xn into log. It is like uv, where u is x to the power of n and v is log x. When this is given, you are asked to prove the in is equal to, that means if you are going to differentiate it n times, that is the meaning of that. Differentiate this nth derivative. Find the nth derivative of the function uv, where u is x to the power of n and v is log x. Then your result must be n factorial into log x plus 1 plus half plus 3 plus 1 plus half plus 1 by 3 plus 1 by 4 up to 1 by n. So this is what we should prove. Okay. See, there is an art, or there is a technical way of approaching the problem. Okay, that you will acquire only when you do lot of problems and understand the subject well. Okay. Now let me write this as d to the power of, see, you see that d to the power of n minus 1 divided by dx to the power of n minus 1 multiplied by this. See, d into d to the power of n minus 1 is d to the power of n. Dx into dx to the power of n minus 1 is your d to the power of n. So I can split this and write this as d to the power of n minus 1. That means first find the first derivative of this, and then go for finding the n minus 1 derivatives of the function. Okay. Now, what is this first derivative of this? Xn into differentiation of log x. To use uv method, product method, u into dv by dx plus v into du by dx. So this is x to the power of n into differentiation of log x is 1 by x plus log x, you keep it as it is, and differentiate x to the power of n. So x to the power of n is n into x to the power of n minus 1 into log x. So what is that we have got here? In is equal to d to the power of n minus 1 divided by dx to the power of n minus 1. This x to the power of n divided by x is nothing but x to the power of n minus 1 plus n into x to the power of n minus 1 plus log x. Now you take this d to the power of n minus 1 inside. So what will happen here is, so I'll write it here, see, here you will find this is d to the power of n minus 1 dx to the power of n minus 1 into x to the power of n minus 1 plus d to the power of n minus 1 dx to the power of n minus 1 into n multiplied by x small n minus 1 log x. So this is what you will get. Now if you are going to differentiate this, see, this is, it is like this. If you are going to differentiate that n times y, n minus 1, what will happen next one? N minus 1 into x to the power of n minus 2. See, here it is, extra, see, it is here. Next, if you differentiate this is n minus 1 into x to the power of n minus 2. The next derivative will be n minus 2. So when you differentiate this, it will become as, when you go for the n minus 1 derivatives, n minus 1 into n minus 2 into n minus 3 up to 1 it goes. So when you are going to do the successive differentiation for this, then it is nothing but what? Here it will be like this, n minus 1 into n minus 2 dot 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 up to 2 1. So this is what you will get. That is why I write this as n minus 1 factorial. So this is how you get this. N minus 1 into n minus 2 into n minus 3 up to 2 1. Therefore this is n minus 1 factorial. Coming to this part, you see that this is nothing but, see, you forget this, I will write this x here again outside because n is a constant. So d into d to the power of n minus 1 divided by dx minus 1 into, you can find that this is nothing but, see, this is same as this. This is same as this except for the n minus 1th derivative. You can just see that this is the n minus 1, if you are going to find the n minus 1 the derivative of x to the power of n minus 1 log x. So in this place we can very well write this as, identify this as n minus 1. So how will you identify? So you must be able to identify this. If it is in, it is d to the power of n divided by dx to the power of n into x to the power of n log x. If it is n minus 1, d to the power of n minus 1 divided by d to the power of x to the power of n minus 1 into x to the power of n minus 1 into log x. If it is n minus 2, in minus 2 is equal to d to the power of n minus 2 divided by dx to the power of n minus 2 into x to the power of n minus 2 log x. So this pattern will go on. So for this I am able to get the result n minus 1 factorial. Can you see this? So this is what I will get. So this is what I get. This is the one, see. This one, in is equal to, see. This is what you will get. See, here you will get. This in is equal to this one. So this is nothing but in. Can you see this? So this is nothing but, see, I will write this. So you will get this as in is equal to n minus 1 factorial. In is equal to n minus 1 factorial into, this is d to the power of n minus 1, n into in minus 1. Can you catch how do I get this? So in, I am able to write it in this fashion. So I explained to you how do you get this. When you are going to differentiate this successively again and again, then Ultimately, you will get what? N minus 1 into n minus 2 up to 2, 1. Therefore, you will get n minus 1 factorial. Into this n can be taken outside. So, this you identified as in minus 1. In. So, we have got in is equal to n minus 1 factorial. See, in is equal to n minus 1 factorial into plus n into in minus 1. So, this is the ultimate result that I want. Once you get that result, means the rest of the things we can make it easy. In the sense, write this here, in is equal to n minus 1 factorial plus n into in minus 1. Now, I will divide throughout by factorial n. When you divide this by factorial n, it is divided by factorial n. And coming to this is n by, see, n divided by factorial n. That is nothing but n divided by 1 into 2 up to n minus 1 into n. Factorial n means what? If this is whatever, that is, you will get is 1, 2 up to n minus 1 into n. This is your factorial n. So, this n and n will go off, giving you what? 1 by n minus 1 factorial. So, that is why you get 1 by n minus 1 factorial. Okay. Plus is equal to, you can find that this is n minus 1 factorial. N minus 1 factorial divided by n factorial. That is n minus 1 factorial divided by n factorial, n minus 1 factorial into n. So, these two will get cancelled, giving you what? 1 by n. So, when you, after getting this, you divide throughout by factorial n. When you divide this by factorial n, in by factorial n minus in minus 1 divided by n minus 1 factorial, I have explained to you how I am getting that result, is equal to 1 by, see, it is 1 by n. This also I explained to you how I get that result. Okay. Now, coming to this in minus 1. Let me write, see, you have got in this similar fashion. Now replace this. When you are going to do this in minus 2, in minus 1, write this in minus 1, see, in the place of in minus 1, you write it as dn minus 2 divided by dx to the power of n minus 2, d by dx of this. Proceed in the similar way. Proceed in the similar as we have done here. If it is d to the power of n minus, see, you have got here d to the power of in minus 1 means what? In d to the power of n minus 1 divided by this into x and log x. Split this as, how will you write this in minus 1? See, you will write this in minus 1 as d to the power of n minus 2 dx to the power of n minus 2 into d by dx of x and log x. So, this is, for this in minus 1, you will write, for this in minus 1, you can proceed as in the first case. See, this is how we have done that. Now, the simplest way to understand this is, replace this in by in minus 1. That means what? In minus 1 will be equal to, see, in minus 1 will be equal to in minus 2 factorial plus, see, I have written here, in minus 1 is equal to n minus 2 factorial plus n minus 1 into in minus 2. Can you see the pattern here? In is equal to n minus 1 factorial plus in minus 1. I have explained to you the working here. Use the very similar method, then you will get the value of this in minus 1 is equal to in minus 1 is equal to n minus 2 factorial plus n minus 1 into in minus 2. Now, divide throughout by n minus 1 factorial. Divide throughout by n minus 1 factorial. When you divide throughout by n minus 1 factorial, you will get it as in minus 1 divided by n minus 1 factorial minus, the next one will be in minus 2 divided by n minus 2 factorial equal to 1 by n minus 1. The next one you will take this to be, see, I have written here, in minus 2. Next one you will get in minus 2, I have this one. So, in minus 2 will be equal to what? In minus 2 will be equal to n minus 3 factorial plus n minus 2 into in minus 3. So, when you divide this one, see, so we have to divide this throughout by n minus 2 factorial. So, when you divide, the next one will be in minus 2, see, in minus 2 divided by n minus 2 factorial minus in minus 3 by n minus 3 factorial is equal to 1 by n minus 2. So this pattern will go on. Now add. See, take this and add. When you add, see this in minus 1 plus this crosswise, this, and this one and the previous one will get cancelled. So this is the pattern of cancellation. So when you go for adding, add all these things or add the terms. So add this with this with this. When you add this, this is minus in minus 1 by in minus 1 factorial. This is plus. So they will get crossed like this. This one and this one, this one, this. So they get cancelled like this, leaving you with what? In, see, in by n factorial minus I1 by 1 factorial. 1 factorial is 1. So in by n factorial minus I1 by 1 is equal to, so this is nothing but what? Half. See, it is half. The previous one is 1 by 3. It is 1 by 3. The previous one by 1 by 4. So 1 by 5, 1 by 6. So it is slowly increasing. 1 by 2, 1 by 3, 1 by 4, 1 by 5. Then 1 by 1 minus n. Then n. So you have to add. That is half plus 1 by 3 plus 1 by 4 plus 1 by 5 up to 1 by n. So in by n factorial is equal to this one. So in by n factorial is equal to I1. Take this I1 to the right hand side. It is I1 plus half plus 1 by 3 plus up to n. But what is your I1? So wherever here you see that in. Put wherever n comes, you put it as 1. So I1 will be equal to d to the power of 1 divided by dx to the power of 1. See? D to the power of 1 divided by dx to the power of 1 into x log x. That means find the first derivative of x log x. Now x into differentiation of log x is 1 by x plus log x, differentiation of x is 1. So I1 will be equal to 1 plus log x. So I am justified in replacing this I1 by 1 plus log x. So what is that I have got here? In by n factorial. I will put it like this now. In by n factorial. In by n factorial is equal to I1, that is nothing but log x plus 1 plus half plus 1 by 3. That means your in, you cross multiply, in is equal to factorial n into log x plus 1 plus 2 plus 3 up to 1 by n. That is what we have to prove here. See, this is these two outputs. So we have to prove this. So here you see that besides knowing how to differentiate, a small technical approach will get you the answer. So this is a, see, know that this in, you can once if you can write this in, replace it in minus 2. If you replace it by n minus 1, correspondingly you will get the result. If you replace it by n minus 2, corresponding result you get. Then you add, you see that you are able to get this. So this is how we do.